All right, so let's look at some basic graphs of logarithms. We've done graphs of exponentials, and we saw that we had a different graph when our base was greater than 1 and when our base was a fraction between 0 and 1. And the same thing is true of logarithms. So let's graph log base 2 of x. Notice this little bitty base is bigger than 1. So let me use our draw feature here. And let's note that our base, in this instance, is greater than 1. So when we have a base bigger than 1, first of all, we're going to have 2 points that always occur in our logarithmic graphs. The first point is 1, 0. That will always be in any logarithmic graph. Or any basic logarithm graph. And then we have the point, in this case, 2, 1. And the point 2, 1 comes from the base and 1. So this is 2, 1. Oops. That 2 comes from the base. So if this was log base 3, we'd have 3, 1. If this was log base 4, we'd have 4, 1, and so on. All right, and then here is what the graph looks like when the base is bigger than 1. All right, now let's notice some features of this graph. First of all, of course, these 2 points, we've noted those, but we have a vertical asymptote of the x-axis, or sorry, of the y-axis, I mean. We also have a graph that is increasing. And let's notice that it increases from where it starts. And if we think about where it starts, it really isn't over here on the left side of our y-axis. None of the negative x values are covered. So it starts at 0 for x. Think of your x values of 0. It starts at 0 and goes to infinity. And 0 is not included. Never actually gets to 0. All right, now our domain is exactly where it's increasing. 0 to infinity. Our range, though, it does go down forever and it goes up forever. So our range is negative infinity to positive infinity. And notice this passes the horizontal line test, so it is 1 to 1. And that means, of course, that it has an inverse. Now, its inverse is the exponential function of the same base. So log base 2 actually has an inverse of 2 to the x. And let's draw 2 to the x. Let's just recall from earlier when we were doing the exponential graphs, 2 to the x will always go through 0, 1, and it will go through 1 and its base, 1, 2. 1, 2 would be right there. And remember that it is an increasing graph that looks like this. Now, recall that all inverse functions are symmetric about the line y equals x, and that's this line going right through here. And of course, it's not perfect, but if I had drawn things perfectly and we folded it along this dotted line, these two functions would land on top of one another because they are inverses. All right, now, we now know what log base 2 of x looks like, the green graph here. Let's take a look at where we have a base that is a fraction between 0 and 1. So here, let's notice the base, the 1/2, is between 0 and 1. Now the good news is most of the things that we had up here are still true. It's still going to go through 1, 0, and it's still going to go through the base 1. So with that in mind, it's going to go through 1, 0, and the base 1. Our base is a half, so 1/2 1. So 1/2 1 is going to be right there. And then here's the shape of this graph. Notice it still has a vertical asymptote of the y-axis. It's going very close to the y-axis but never reaches it. So it still has a vertical asymptote, so I'll just sort of mark that. All right, but let's note that this graph is not increasing, it's decreasing from 0 to infinity. However, everything else, every other characteristic that we had above, is the same for this graph. It still has domain from 0 to infinity. Notice there's nothing over here. It has a range of negative infinity to positive infinity, and it passes that horizontal line test, so it's 1 to 1. And of course, it has an inverse. Its inverse is y equals 1/2 to the x power. All right, so notice though, you always, if the base is bigger than 1, are going to have a graph that looks like this green one. If the base is a fraction, going to have a graph that looks like this blue one. Now, let's take a look at y equal natural log of x. In the last video, we talked about the natural log. The natural log has an unwritten base of e. And remember that e is approximately 2.718. All right, so that's a base bigger than 1, which means its graph is going to look like this one right here. It's going to go through 1, 0, and 2.7181. So with that in mind, let's draw it. It's going to go through 1, 0, and 2.7181. So 2.718 is about there, and 1 right here. And it looks like that. Now we're going to transform logarithms. All right, and let's realize if we have a logarithm with a base bigger than 1, we're going to start with an original function that looks like this. And if we have a logarithm with a base that's a fraction, we're going to start with an original function that looks like this. Now, the nice thing about the logarithms is that all of the transformations that we studied before when we did transformations back on exam 2 are in the same place. So they're not hidden like they were with exponentials. So we can very easily identify things in the same way that we did before when we were doing transformations. Recall that if we added or subtracted something to a function before, it was a vertical shift. So this is going to take it down 3. And that's still exactly the same as it was before. All right. Remember that if we added something inside the parentheses or inside an operation of a function, and this is inside of the logarithm, then that is a horizontal shift, always in the opposite direction. So this is going to take it left 1. Remember, if we had a negative in front of our function, that was a reflection across the x-axis. And then if we had a number that was greater than 1, that stretched the graph by a factor of, in this case, of 2. Now remember, if that was a fraction, such as a half, it would have been a compressing by a factor of whatever the fraction was. All right, now, let's start with what our library function is. We have a little bitty base of 3, meaning we are going to start with a logarithmic function that has this shape. Since the base is bigger than 1, it's going to go through 1, 0, and 3, 1, since our little bitty base is 3. So let's draw a logarithmic function going through 1, 0, and 3, 1. And it's very important that we recognize also that we have a vertical asymptote right there on the y-axis. All right, so let's start. This down 3 must go last. It always has to be the last thing we do. So let's do our left one first, and I'll change colors to show the new graph and do it right here on this graph. So if I take my 2 points, left one, this one will end up right here, and this one will end up right here. And let's remember the vertical asymptote that was right here will end up at -1. So I'm going to make a dotted line to represent the new vertical asymptote. Okay, so now if we go ahead and draw it, I know it's not very straight. All right, it's going to look like that. All right, so I've moved it left 1. Now let's reflect that across the x-axis. So again, I'll just change colors. All right, so if I think of this piece right here reflecting across, this point will stay where it is, but this point will end up right there. And this piece would reflect across this way. I know it's not perfect, but, and then this piece will end up going upward like this. All right, so there's the reflection. Now let's stretch it by a factor of 2. Now let's notice that this new point right here is at 2, -1. So when we stretch by a factor of 2, we're going to multiply the y values by 2. And then this point right here is 0, 0. All right, so let's stretch both of those points. And I'll draw a new graph just because it's getting kind of busy. All right, so if I multiply this y value by 2, it's still 0, 0. So we're still going to have it going through 0, 0. But if I multiply this y value by 2, we'll get 2, -2. Notice it's only the y value. So it's going to end up there. And then I still have that asymptote. So now that we've stretched the graph, it's going to look like that. I missed, but you get that general idea there. All right, now let's do the last thing. Let's take this graph down 3. And I will again change colors. I'll do it on the same graph here. 1, 2, 3. All right, so if I take this point down 3, 1, 2, 3, and I take this point down 3, 1, 2, 3, my new graph is still going to head toward that asymptote, but it is further down. And again, I'm having trouble keeping it nice and straight. You should be able to do better than trying to draw with your mouse on paper. All right, and there we go.